Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home on your commute or winding down for the evening, I'm really glad you're here. Now, I want you to imagine something with me for a moment. Picture waking up tomorrow morning. Maybe it's a Tuesday. Maybe you've got your usual routine planned. You reach for your phone to check the time, and it reads 6:43 a.m. Pacific time. But instead of your normal alarm, you hear something else. Sirens. Not the kind you hear during an earthquake drill in California. Not the familiar wail of an ambulance rushing down the street. These are different. These are the kind of sirens that make your blood run cold because you've never heard them before. And somehow, deep in your gut, you know they mean something impossible has happened. You stumble to your window, maybe in San Francisco, maybe looking out over what should be the Pacific Ocean, stretching endlessly toward the horizon. But here's the thing, and I need you to really picture this. The ocean isn't there anymore, not receding like some massive low tide, not pulled back like before a tsunami, gone, completely, utterly gone. Where just hours before, 11,000 feet of water pressed down near the Golden Gate Bridge, you're looking at naked seafloor. Wet, dark sand and sediment spreading as far as you can see. The continental shelf, usually hidden beneath hundreds of feet of Pacific water, is just sitting there in the morning light like some alien landscape that was never meant to be seen by human eyes. Now, you might be thinking, okay, that's impossible. That's literally impossible. And you'd be right to think that. But bear with me here because what I'm about to tell you gets so much wilder. Picture a Japanese fisherman named Takeshi. He's been working these waters for 37 years, knows every current and every seasonal change like the back of his weathered hands. At 6:43 a.m. Pacific time, which is 10:43 p.m. his time, he's out on his trawler about 50 miles off the coast of Hokkaido. The sea is calm, the kind of peaceful night fishing that makes all the hard work worthwhile, and then his boat drops. Not rocks back and forth with the waves, not settles a little lower as he takes on a catch. It drops like an elevator, 500 feet down in about 30 seconds, settling with a bone-jarring thud onto what used to be the ocean floor. Takeshi sits there in his wheelhouse, engine still running, listening to his radio explode, with panicked voices, speaking in a dozen different languages, all saying the same impossible thing. The water is gone, all of it, from Mumbai to Miami, from the Arctic Ocean to the Southern Ocean surrounding Antarctica. 321 million cubic miles of water have simply vanished. In an instant. No warning, no gradual change, no explanation that makes any scientific sense whatsoever. You know what's really wild about this moment? There's a cruise ship called the Queen Mary 2 out there in the middle of the Atlantic. Picture this. 3,200 passengers, probably finishing up dinner service, maybe catching the evening show, completely unaware that their floating city is about to become something else entirely. In the space of a heartbeat, their ship doesn't sink. It falls, straight down through empty air that used to be ocean, until it settles with a tremendous crash on the mid-Atlantic ridge, 2.5 miles below where the surface of the Atlantic used to be. Can you imagine being one of those passengers? 1 second you're sipping wine and watching the evening entertainment. The next second, your entire world lurches downward, and you're sitting in a ship on the bottom of what used to be the ocean, looking up at stars you could never see before through 2.5 miles of air that used to be water. But here's where it gets even crazier. Remember Flight 773, the red-eye from London to New York? They're cruising at 37,000 feet when every single altimeter on the aircraft starts giving readings that don't make sense. The pilots are trained for a lot of emergencies, but the ocean disappeared, and now our altitude measurements are completely wrong, isn't covered in any manual. The air pressure is plummeting because suddenly there's 139 million square miles of new volume for the atmosphere to fill. They have to make an emergency landing because every instrument that depends on barometric pressure, which is basically everything that keeps a plane in the air safely, is now giving readings that are completely useless. Meanwhile, up in space, Weather satellites are capturing images that no human being has ever seen before. You know that famous picture of Earth from space, the blue marble photo that shows our planet as this beautiful blue and white sphere hanging in the blackness. Well, now those satellites are sending back images of a brown and grey planet. The blue is gone. Just gone. At Woods Hole Oceanographic Institution in Massachusetts, there's a marine biologist named Sarah Chen who's been studying the deep ocean for 15 years. She's got cameras positioned all over the ocean floor, from the shallow continental shelves down to the deepest trenches. She's watching her monitors when, one by one, her deep-sea cameras start going dark. Not malfunctioning, not being destroyed, just losing their signals as the water that carried those signals disappears. The last image she receives comes from the Mariana Trench, the deepest part of any ocean on Earth. 36,000 feet below what used to be sea level, her camera captures something that will haunt her for the rest of her life: giant isopods. These bizarre deep-sea creatures that look like enormous pillbugs, crawling around on exposed rock, clearly confused and disoriented. They're moving in circles, these ancient creatures that have lived in total darkness under crushing pressure for millions of years, now suddenly exposed to air they've never breathed, under a sky they've never seen. Think about that for a second. These animals, their entire evolutionary history, everything about how they're built and how they survive, is based on living under the pressure of 6 miles of water. And now they're just sitting there on dry rock, experiencing something that no member of their species has ever experienced in the entire history of life on Earth. But here's what Sarah Chen realizes as she's watching this impossible footage. This isn't just about the animals. It's not even just about the missing water. Every single system on our planet, the weather, the climate, the very rotation of the Earth itself, depends on those oceans being there. And now they're not. She starts pulling up data from seismic monitoring stations around the world, and what she sees makes her hands shake. Within just the first hour after the water disappears, the seafloor starts doing something that should be impossible. It starts moving, rising. The Atlantic Ridge, which normally sits under 2 miles of crushing ocean water, suddenly doesn't have 15,000 pounds per square inch of pressure holding it down anymore. You know what happens when you take a huge weight off a compressed spring? It rebounds. And that's exactly what the ocean floor starts doing, but on a scale that defies imagination. The Atlantic Ridge rises 3,000 feet in the first 60 minutes. 3,000 feet. That's like watching a mountain range grow from the ground up faster than you can run. California's continental shelf, the underwater extension of the coastline that slopes down toward the deep Pacific, lurches upward 800 feet. 800 feet of vertical movement in less than an hour. The earthquake that triggers is magnitude 9.3, stronger than anything in recorded history. But it's not just California. Alaska to Chile. Every fault line along the Pacific Ring of Fire activates simultaneously, and that's just the beginning. The atmosphere starts rushing to fill all that new space where the oceans used to be. Think about it. You've suddenly created 139 million square miles of new volume that air needs to fill. The wind speeds hit 400 miles per hour as air pressure tries to equalize. The jet stream, that river of fast-moving air that controls weather patterns across the northern hemisphere, just collapses. Then it reforms, but in completely chaotic new patterns that meteorologists have never seen before. There's a hurricane called Patricia that's been churning toward Mexico with 200-mile-per-hour winds, a monster storm that weather services have been tracking for days. As the atmosphere reshuffles itself, Patricia just dissolves. The pressure differentials that were feeding it disappear, and this massive hurricane simply ceases to exist. But nature abhors a vacuum, and in the place where Patricia was, something new starts forming. Over the exposed Pacific Basin, where the largest body of water on Earth used to moderate temperatures, the temperature differences between the surface and the upper atmosphere become extreme. A superstorm begins to form, not a hurricane, not a tornado, but something entirely new. the most violent weather system ever recorded, fed by temperature differentials that have never existed before in Earth's history. And then the volcanoes start waking up. Mount Fuji erupts first, then Vesuvius. Then in what scientists will later call the most terrifying development of the entire catastrophe, Yellowstone. Without the pressure of ocean water, magma chambers worldwide start destabilizing. These underground reservoirs of molten rock have been held in delicate balance for thousands of years, and suddenly that balance is gone. 112 dormant volcanoes erupt in the first 24 hours. 112. Volcanoes that haven't been active in human memory suddenly come roaring back to life, spewing ash and lava into an atmosphere that's already chaotic from the missing oceans. But there's something else happening that's even more fundamental. Something that most people don't think about, but that affects every single system on our planet, the moon. Our moon has been pulling on Earth's oceans for billions of years, creating tides, influencing the rotation of our planet in ways so subtle that we barely notice them. But now, without that massive volume of water for the moon to pull on, Earth's rotation starts changing. 23 minutes. That's how much faster Earth starts spinning each day. It doesn't sound like much, but when you're talking about a planet that's been rotating at exactly the same speed for all of human history, 23 minutes is catastrophic. GPS satellites lose synchronization. Every computer system that depends on precise timing, which in our modern world is virtually everything, starts failing. Navigation systems fail. Communication networks go down. Financial markets, which depend on split-second timing for transactions, simply stop functioning. In the space of a few hours, human civilization doesn't just lose its oceans. It loses its ability to coordinate itself on a global scale. Now I want to take you deeper into what this really means. Because what we've been talking about so far, the physical changes, the immediate chaos, that's just the beginning. Within 1 hour of the oceans disappearing, Earth starts convulsing in ways that reveal just how dependent everything is on those massive bodies of water that we took for granted. Here's what's really wild about this physics nightmare. Every square foot of ocean floor has been experiencing 15,000 pounds per square inch of pressure for millions of years. And suddenly, in the span of a heartbeat, that pressure is gone. Imagine if you took 1,000-pound weight off a springboard and watched it snap back up. Now imagine that happening to an area the size of continents. The seafloor rebounds like the Earth's crust is made of rubber. California's continental shelf doesn't just rise 800 feet, it keeps rising. By hour 2, it's up 1,200 feet. By hour 4, it's risen a full mile. The Monterey Canyon, which used to be this incredible underwater gorge that marine biologists love to explore, is now a dry canyon twice as deep as the Grand Canyon, sitting there in the open air like a wound in the earth. But here's where the physics gets truly terrifying. All that movement, all that sudden shifting of massive chunks of the Earth's crust triggers earthquake after earthquake after earthquake. We're not talking about one big quake and then aftershocks. We're talking about continuous seismic activity that doesn't stop. The magnitude 9.3 that hit California in the first hour. That's followed by a 9.1 in Alaska, then a 9.0 in Chile, then an 8.8 in Japan, the Pacific Ring of Fire, that horseshoe-shaped zone of volcanoes and fault lines that surrounds the Pacific Ocean basin activates all at once. It's like someone flipped a switch and turned on every single geological hazard in the most seismically active region on Earth simultaneously. And remember, this isn't happening in isolation. The atmosphere is going absolutely berserk, trying to fill 139 million square miles of new volume. The air pressure at sea level drops by 30% in the first 6 hours. 30%. Do you know what that means for human beings? For aircraft? For any system that depends on atmospheric pressure to function. People living at what used to be sea level suddenly find themselves experiencing the equivalent of being at 14,000 feet of elevation. That's higher than most mountains in the continental United States. Everyone is gasping for breath, getting altitude sickness, feeling like they've been transported to the top of a mountain without any acclimatization. Commercial aircraft become unflyable. The pressure differential that keeps planes in the air depends on predictable atmospheric conditions, and suddenly there are no predictable atmospheric conditions. Every airport in the world grounds every flight because the instruments can't compensate for pressure changes that are happening faster than the computers can calculate them. But the most terrifying part isn't the immediate chaos, it's what happens to the weather. Without oceans to moderate temperature, the land masses start experiencing temperature swings that are beyond anything in human experience. The Sahara Desert, which used to be hot during the day and cold at night, starts swinging from 150 degrees Fahrenheit during the day to -50 at night. Every single day, the former ocean basins, now exposed to direct sunlight and nighttime cooling, become these massive heat engines driving weather patterns that meteorologists can't even categorize. Tornadoes form over what used to be the Pacific, not waterspouts. Actual tornadoes, spinning over dry land that's never experienced tornado conditions before. And then there's the wind. Oh, the wind. 400 miles per hour might sound like an exaggeration. But here's the thing. When you suddenly create 139 million square miles of new volume that air needs to fill, physics doesn't care about what sounds reasonable. The jet stream doesn't just shift, it fractures into multiple streams moving in completely unpredictable directions. Hurricane Patricia dissolving isn't unusual. Every weather system on Earth dissolves because the conditions that created them no longer exist. But new systems form almost immediately, and they're unlike anything that's ever been recorded. The superstorm that forms over the exposed Pacific Basin generates winds that make Hurricane Patricia look like a gentle breeze. Picture this. A storm system the size of the entire former Pacific Ocean, with no water to moderate its intensity, driven by temperature differentials between the exposed seafloor and the upper atmosphere that are more extreme than anything that's ever existed on Earth. It's not a hurricane. Hurricanes need warm ocean water to form. It's not a tornado. Tornadoes need specific atmospheric conditions over land. It's something entirely new, something that there's no name for, because it's never existed before. Now, let me tell you about the volcanoes, because this is where the story gets really intense. Mount Fuji erupting first isn't a coincidence. It's the result of pressure changes that affect every magma chamber on Earth simultaneously. For thousands of years, these underground pockets of molten rock have been held in a delicate balance between the pressure of the rock above them and the pressure of the water bearing down on the Earth's crust. When the oceans disappear, that balance shifts everywhere at once. Vesuvius, which last erupted in 1944, suddenly has its magma chamber destabilized. Yellowstone, the supervolcano that's been dormant for over 70,000 years, feels the pressure change and starts showing signs of activity that geologists have only seen in computer models of worst-case scenarios. But it's not just the famous volcanoes. 112 dormant volcanoes erupt in the first day, and that number keeps climbing. Volcanic systems that have been inactive for so long that they're not even on geological hazard maps suddenly come roaring back to life. The Ring of Fire becomes literally a ring of fire, with volcanic activity from Alaska to Chile to Japan to New Zealand happening simultaneously. The ash clouds from these eruptions start interacting with the already chaotic weather patterns in ways that create entirely new atmospheric conditions. Volcanic ash, mixed with 400-mile-per-hour winds, creates abrasive storms that can strip paint off buildings and flesh off bones. The sky over much of the northern hemisphere turns a permanent dark grey as ash clouds circle the globe in the disrupted jet streams. And through all of this, the moon keeps pulling on Earth. But now it's pulling on a planet that doesn't have the massive stabilizing influence of the oceans. Earth's rotation speeds up by 23 minutes per day initially, but it doesn't stop there. The angular momentum that was distributed across all that ocean water is now concentrated in the solid mass of the planet. And physics demands that things speed up even more. By the end of the first week, days are 45 minutes shorter. By the end of the first month, days are 2 hours shorter. The implications of this are staggering. Every biological system on Earth, from the simplest bacteria to the most complex mammals, has evolved around a 24-hour day. Plants photosynthesize on a 24-hour cycle. Animals sleep and wake on a 24-hour cycle. Human beings have circadian rhythms locked to a 24-hour cycle. Suddenly, none of that works anymore. It's not just that GPS satellites lose synchronization, though they do, making navigation impossible. It's not just that computer networks fail, though they do, making communication increasingly difficult. It's that every living thing on Earth is suddenly operating on a schedule that doesn't match the planet's new rotation. The financial markets collapse not because of panic, though there's plenty of that, but because the timing, systems that coordinate global trading, can't keep up with a planet that's spinning faster every day. Power grids fail because they're synchronized to a planetary rotation that no longer exists. Internet infrastructure breaks down because the precise timing that coordinates data transmission around the world is based on a rotational speed that Earth no longer maintains. But you know what's really going to blow your mind? This is still just the immediate response. This is still just the first week of a planet learning how to exist without the thing that has defined it for 4 billion years. Because what comes next? The biological collapse, the chain reactions through ecosystems, the ways that life itself has to adapt or die. That's where this story becomes something beyond science fiction. The Earth we knew, the blue planet that has been humanity's home for our entire existence as a species, is gone. What's taking its place is something alien, something that operates by different rules, something that's going to test every assumption we've ever made about how life works on a planetary scale, and the clock is ticking faster every day. So we've covered the immediate physical chaos, the earthquakes, the weather, the volcanic eruptions, the changing rotation of the planet. But now I want to talk about something that's going to hit you right in the gut, because it's about life itself. About 20 billion tons of it, to be exact. Picture this: every single marine animal on Earth, from the tiniest plankton to the largest blue whales, suddenly finding themselves in a situation that no creature in the history of evolution has ever faced. They're not dying from pollution or climate change or overfishing. They're facing the complete and instantaneous removal of their entire world. 20 billion tons. That's not just a number. That's every fish, every whale, every shark, every sea turtle, every jellyfish, every coral polyp, every piece of seaweed, every microscopic organism that calls the ocean home. And in the span of a single moment, their home doesn't just change, it ceases to exist. The blue whales are probably the most heartbreaking. These magnificent creatures, the largest animals that have ever lived on Earth, larger than any dinosaur, suddenly find themselves falling. Not swimming, not diving, falling. From heights of 6,000 feet in the deep ocean, they crash onto the Pacific floor with impacts that register on seismographs. Can you imagine the sound? These gentle giants who communicate through songs that can travel hundreds of miles underwater, suddenly experiencing something that their species has never known, the sensation of falling through air instead of gliding through water. The impacts when they hit the seafloor create craters that will be visible for thousands of years. But it's not just the large animals. In the Monterey Canyon, which is now this incredible dry gorge, exposing layers of seafloor that have been hidden for millions of years, there are pools of rapidly evaporating seawater trapped in the deepest crevices. Millions of fish are trapped in these shrinking pools, gasping in water that's becoming more and more concentrated with salt as it evaporates. Schools of tuna, creatures built for speed and endurance in the open ocean, are flopping helplessly on the exposed continental shelf. Dolphins, those intelligent marine mammals that have inspired humans for centuries with their playfulness and apparent joy in living, are dying in the open air, their complex social structures dissolved in an instant of planetary catastrophe. But here's where the story takes a turn that's going to surprise you. Because life, and I mean this literally, life finds a way, even in the face of the most catastrophic extinction event in the history of the planet. Some creatures not only survive, but begin adapting in ways that seem impossible. In the deepest ocean trenches, which are now these incredible dry canyons cutting miles down into the Earth's crust, pockets of briny water remain trapped by rock formations. The water is incredibly salty, more concentrated than anything that existed in the original oceans, and it's sitting in basins that are now exposed to air and experiencing temperature changes that would kill most life forms. But remember the Pompeii worm, this incredible creature that was already living near volcanic vents at the bottom of the ocean, thriving in water temperatures of 700 degrees Fahrenheit? These worms don't just survive the transition, they start changing. Within 72 hours, 3 days, some of them develop what can only be described as primitive air sacs. Not lungs like mammals have, but simple chambers that can extract oxygen from air instead of from water. In 3 days, these creatures begin evolving the ability to breathe air. 3 days. Now I know what you're thinking. Evolution doesn't work that fast. Evolution takes thousands of years, millions of years, to produce significant changes. And you'd be right under normal circumstances. But these aren't normal circumstances. The selective pressure, the environmental force that drives evolution, is absolute. Adapt immediately or die immediately. In some life forms, the ones with the most flexible genetics, the ones that were already living in extreme conditions, start changing faster than anyone thought possible. Deep-sea bacteria, those microscopic organisms that form the base of many ocean food webs, do something even more incredible. They enter what scientists call crystalline states. Essentially, they turn themselves into living crystals that can remain dormant for decades if necessary. They're not dead, but they're not actively living either. They're waiting. Waiting for what? Nobody knows. Maybe they're waiting for conditions to change. Maybe they're waiting for new opportunities to emerge. Maybe they're just buying time while the planet figures out its new normal. But the fact that they can do this at all suggests that life has backup plans that we never imagined. The most remarkable adaptation, though, happens with a species of Japanese mudskipper. Now, mudskippers are already pretty amazing fish. They can leave the water and walk around on land for short periods, breathing air through their skin and their gill chambers. They're like evolutionary experiments in the transition from water to land. But after the oceans disappear, some mudskippers that were stranded in the Japan Trench, which is now this incredible canyon system, stretching down almost 7 miles into the earth, start changing at a rate that breaks every rule of evolutionary biology. Within 6 months, their descendants aren't just breathing air, they're climbing the walls of the trench. They've developed stronger fins for locomotion on land, more efficient air-breathing systems, and behavioral changes that allow them to hunt terrestrial insects that fall into the trench. 6 months. From fish to land animal in 6 months. It's the most rapid evolutionary change ever documented, and it's happening because the alternative is extinction. But for every success story, there are thousands of tragedies. On land, the collapse of marine ecosystems triggers a domino effect that ripples through every ecosystem on Earth. You see, 50% of the oxygen we breathe comes from ocean phytoplankton, those microscopic plants that float in the surface waters of the sea. With the oceans gone, oxygen production drops by half in the first few months. Atmospheric oxygen levels fall from 21% to 16% in 3 months. That might not sound like much, but it's the difference between breathing normally and feeling like you're constantly short of breath. It's the difference between birds being able to fly efficiently and birds falling out of the sky because they can't get enough oxygen to maintain flight. humans start feeling constantly breathless, especially during any kind of physical exertion. Athletes can't perform at their previous levels. People with respiratory conditions find their symptoms getting worse. Children and elderly people who are more sensitive to oxygen levels start experiencing health problems that doctors have never seen before. But the really devastating impact is on the food web. With marine food chains completely destroyed, the billions of seabirds that depend on fish for survival start dying en masse. Not just dying, starving. Puffins, albatrosses, pelicans, terns, all the seabirds that have evolved to feed from the ocean suddenly have no food source. Their deaths, in turn, affect land ecosystems. Seabird guano has been fertilizing coastal and island ecosystems for millions of years. Without that fertilization, plant communities start changing. Insects that depend on those plants start disappearing. Animals that depend on those insects start struggling. It's like watching a tapestry unravel, thread by thread, until the entire pattern falls apart. But nature, as always, writes unexpected chapters. The exposed ocean basins, while they represent the destruction of marine ecosystems, become something unprecedented in the history of the planet. All that decomposing marine life, 20 billion tons of it, creates the richest soil that has ever existed on Earth. Think about it. Millions of years of accumulated organic matter from the ocean floor, mixed with the decomposing bodies of every sea creature that ever lived, all exposed to air and weather for the first time. The chemical processes that start happening in these former ocean basins are like nothing that's ever occurred before. Strange new ecosystems begin emerging. Forests of giant fungi start growing in areas where whale carcasses are decomposing. These aren't normal mushrooms. They're massive fungal structures, some growing 50 feet tall, feeding on the incredible abundance of organic matter. They create these otherworldly landscapes that look more like something from an alien planet than anything that's ever existed on Earth. Arthropods, insects, spiders, crustaceans start growing to monstrous sizes in the oxygen-depleted air. You know how insects were much larger millions of years ago when oxygen levels were higher? Well, now the opposite is happening. With lower oxygen levels, the insects that survive start developing more efficient respiratory systems. And some species start growing larger to maximize their oxygen intake efficiency. Picture spiders the size of dinner plates, cockroaches the size of mice, beetles the size of small dogs. It sounds like a horror movie, but it's actually an amazing example of how life adapts to fill new ecological niches. With the disappearance of many larger predators and the abundance of decaying organic matter, these arthropods are thriving in ways that would have been impossible in the old world. In some of the deeper former ocean basins, where the organic matter is richest and the temperature more stable, entirely new types of ecosystems are forming. Scientists start calling them necrotic gardens, gardens of death that have become gardens of new life. Decomposer organisms that used to work slowly on the ocean floor are now working in air, creating soil so rich that plants grow at unprecedented rates. But the plants that grow aren't the ones we're familiar with. The changed atmospheric conditions, the different soil chemistry, the altered sunlight patterns due to volcanic ash in the atmosphere, all combine to favor plant species that can tolerate the new conditions. Succulents and other drought-resistant plants start spreading rapidly, creating landscapes that look more like Mars than the Earth we knew. And through all of this adaptation and change, one thing becomes clear. The planet that's emerging from this catastrophe isn't just Earth without oceans. It's a fundamentally different planet, operating by different rules, supporting different kinds of life, creating different kinds of beauty and terror than anything that's existed in the 4-billion-year history of our world. The blue planet is dead. What's being born in its place is something entirely new. Now, I want to take you on a journey that's going to blow your mind. Because while billions of creatures are dying and ecosystems are collapsing, humanity is about to gain access to wonders that have been hidden for hundreds of millions of years. We're about to become the first people in history to walk on the bottom of the ocean and see things that no human eyes have ever seen. Picture this: the Atlantic Ocean floor, exposed for the first time in 200 million years, reveals a mountain range that makes the Himalayas look like hills. The Mid-Atlantic Ridge, that massive underwater mountain chain that runs down the center of the Atlantic like a spine, is now fully visible in all its incredible glory. These mountains are taller than Mount Everest, more dramatic than the Rocky Mountains, more extensive than the Andes, and they've been sitting there, hidden under miles of water, shaping ocean currents and influencing global weather patterns without any human ever seeing them. The geological features that are revealed are so spectacular that mountaineers start planning expeditions to climb peaks that were discovered just days ago. But it's not just the natural wonders. The Mediterranean basin, now a vast dry valley 3 miles deep, holds treasures that archaeologists have only dreamed of. In the deepest parts, where the pressure and cold and lack of oxygen preserved everything perfectly, there are Roman galleys that look like they were built yesterday, ships that sank 2,000 years ago. Their wooden hulls intact, their cargo holds still sealed. Wine amphorae that still contain wine. Olive oil jars with their contents preserved. Scrolls wrapped in oiled cloth that can still be unrolled and read. It's like discovering a time capsule from the height of the Roman Empire, preserved in perfect condition by the deep ocean environment. But that's just the beginning. As exploration teams start making their way into the deeper parts of the former oceans, they start finding things that rewrite history. Off the coast of Japan, in what used to be 4,000 feet of water, explorers discover a city, not ruins, not scattered artifacts, a city. Stone buildings arranged in precise geometric patterns with construction techniques that don't match anything in the archaeological record. The preservation is so perfect that you can still see tool marks on the stones, still walk through doorways and corridors, still see what appear to be decorative carvings that suggest an artistic tradition completely unknown to archaeology. Carbon dating of organic materials found in the city suggests it's 50,000 years old. 50,000 years. That predates known civilization by 40,000 years. It suggests that there were sophisticated human societies building monumental architecture when mainstream archaeology says humans were still hunter-gatherers living in caves. Think about what that means. Everything we thought we knew about human development, about the timeline of civilization, about when people first started building permanent settlements and working with stone on a large scale, it's all wrong. The oceans were hiding evidence of human achievement that completely changes our understanding of our own history. In the Puerto Rico Trench, now a spectacular canyon system that's deeper than the Grand Canyon, explorers make an even more mysterious discovery. They find what appears to be worked metal, not iron or bronze or copper, but alloys that don't match anything in our periodic table. The metallurgy is so advanced that our best materials scientists can't figure out how it was made or even what all the component elements are. Some of the metal artifacts appear to be tools, but tools designed for purposes that no one can figure out. Others look almost like art objects, but they incorporate mathematical relationships and geometric patterns that suggest a level of mathematical sophistication that rivals our own. And some of them, this is the part that really makes scientists' hair stand on end, some of them appear to be made from elements that don't occur naturally on Earth. I'm not saying it's aliens, but I'm saying that when you find worked metal made from elements that don't exist in nature on our planet, you have to start asking some very serious questions about what was going on in Earth's history that we never knew about. But let's talk about something more familiar but equally amazing, the technology that's suddenly exposed. The global telecommunications network that spans the ocean floors is now visible in its entirety. 850,000 miles of fiber optic cables, carrying the internet and phone communications around the world. Lying across the former ocean floor like a planet-sized nervous system, you can actually see the physical infrastructure of global communication. You can walk along the cables that carry your emails and video calls and streaming movies from continent to continent. It's like seeing the veins and arteries of the modern world laid out in front of you. This incredible technological achievement that most people never think about because it's normally hidden under miles of water. The Gulf Stream, that massive current of warm water that flows from the Caribbean up the East Coast and across to Europe, moderating climate and weather patterns across the entire North Atlantic, has left its mark on the ocean floor. You can see its path as a vast groove worn in the seafloor over millions of years, like a riverbed, but on a scale that defies comprehension. Standing on the former Atlantic floor and looking at the Gulf Stream's path is like seeing the circulatory system of the planet made visible. You can trace the flow of water that carried warm tropical air to northern Europe, that made England habitable and kept Scandinavia from becoming completely frozen. It's a reminder of how interconnected Earth's systems are, how the movement of water in one part of the world affects weather and climate thousands of miles away. And then there are the methane hydrate deposits. These frozen gas reserves, larger than all known oil and coal deposits combined, are suddenly accessible. Under the pressure of the deep ocean, methane exists as a solid, locked up in ice-like crystals that can only form under very specific conditions of temperature and pressure. With the oceans gone, these deposits are sublimating, turning directly from solid to gas, creating massive clouds of methane that nations are racing to capture. The energy potential is enormous. These deposits could power human civilization for centuries. But they're also incredibly dangerous. Methane is a potent greenhouse gas, and uncontrolled release of these deposits could accelerate climate change beyond anything humans have ever caused. Countries start staking claims to former ocean floor territory with a speed and aggressiveness that makes the 19th century land rushes look polite. The United States claims the entire former Pacific Basin off its coast. Russia claims vast areas of the former Arctic Ocean. China, Japan and Korea get into a three-way territorial dispute over access to the methane deposits in the former Sea of Japan. It becomes clear very quickly that the geopolitics of a world without oceans are going to be completely different from anything humanity has experienced. Coastal nations suddenly have vast new territories to explore and exploit. Landlocked nations, which were never major maritime powers, find themselves disadvantaged in ways they never imagined. The resource war that develops isn't fought with navies. How can you have a navy without an ocean? But with land-based mining equipment, with atmospheric aircraft, with ground forces racing to establish mining operations on former seafloor territory before other nations can get there. But here's what's really incredible about all these discoveries. Robert Ballard, the man who found the Titanic wreck in 1985, can now walk to it. Think about that for a second. This ship, which has been sitting on the ocean floor for over a century, which required sophisticated deep-sea submersibles to reach, which was one of the most challenging archaeological discoveries in history. Now, you can literally walk to it across the dry Atlantic floor. The Titanic sits upright on what used to be the abyssal plain, 2 miles below the former ocean surface. The preservation is remarkable. In the dry air, without the corrosive effects of salt water, metal surfaces that were gradually deteriorating underwater are now stable. Paper documents that survived in sealed compartments are readable for the first time since the ship sank. Walking through the Titanic is like stepping back in time to 1912. You can read newspapers from the day the ship sailed. You can see personal letters that passengers were writing to families back home. You can examine the engineering of the ship, the rivets, the steel plates, the massive engines, with a level of detail that was impossible when the wreck was underwater. But the Titanic isn't alone out there. The former North Atlantic is littered with shipwrecks from across the centuries. The Bismarck, that massive German battleship from World War II, sits not far away. The Lusitania, whose sinking helped bring America into World War I, is now accessible to anyone who wants to walk the few miles across the former ocean floor to reach it. It's like someone created the world's largest maritime museum, except all the exhibits are full-sized original ships that you can walk through and explore. Historians and archaeologists are having the time of their lives, but it's also profoundly sobering. Each of these wrecks represents human tragedy, and now they're all exposed under an alien sky. Monuments to disasters that seemed monumental at the time, but pale in comparison to the catastrophe that exposed them. The exposed fiber optic cables aren't just interesting to look at, they're still functional. Communication companies start sending repair crews out to fix breaks in the cables caused by the sudden exposure to air and the seismic activity from the seafloor rebound. It's surreal. Technicians in protective suits walking across the former Pacific floor, splicing fiber optic cables that are lying on dry ground instead of buried under miles of water. The logistics of maintaining global communications in a world without oceans require completely new approaches. Satellite networks become more important than ever, but the atmospheric chaos from the missing oceans interferes with satellite signals. Companies start stringing cables across the exposed ocean floors like massive telegraph lines, using the former shipping routes as guide paths for the new communication networks. But perhaps the most profound discovery isn't technological or historical. It's geological. The exposed ocean floor tells the story of Earth's 4-billion-year history in ways that scientists never imagined possible. Sediment layers that would have taken decades to drill through and analyze are now exposed on the surface. You can literally walk across millions of years of Earth's history, seeing the geological record of climate changes, mass extinctions, volcanic periods, and ice ages laid out like pages in a book. Scientists discover evidence of 12 previous mass extinction events that were unknown before the oceans disappeared. Some of these extinctions were even more severe than the one that killed the dinosaurs. In the deepest trenches, they find fossil evidence of life forms that don't fit into any known category of Earth biology. Creatures so alien that they suggest life on our planet has been far stranger and more diverse than anyone imagined. Most remarkably, they find evidence that Earth's oceans have disappeared before. Not completely, and not for as long. But 65 million years ago, the same asteroid impact that killed the dinosaurs temporarily vaporized a significant portion of the world's oceans. The geological evidence shows that the oceans were reduced to isolated seas and lakes for approximately 3 days before the vaporized water condensed and returned as the most torrential rainfall in planetary history. Life barely survived that event. The fossil record shows that it took millions of years for ecosystems to recover. But this time, there's no asteroid impact that's going to reverse itself. This time, the water isn't coming back. Earth is writing an entirely new chapter in its biological and geological history, and humanity is along for the ride, whether we're ready or not. The treasures of the abyss aren't just scientific or historical curiosities. They're resources that could reshape human civilization. The methane hydrates alone represent more energy than humanity has ever used in its entire history. The rare earth elements concentrated in deep-sea volcanic vents could revolutionize technology. The pure metals precipitated by underwater volcanic activity over millions of years could solve resource scarcity for generations. But accessing these resources requires adapting to a world that operates by completely different rules. The temperature extremes in the former ocean basins make them almost uninhabitable during certain parts of the day. The atmospheric pressure at the bottom of the deep trenches is so different from the surface that workers need pressure suits. The geological instability from the ongoing seafloor rebound makes construction and mining operations incredibly dangerous. It's like humanity has suddenly inherited an alien planet's worth of resources and mysteries. But accessing them requires learning how to live and work in conditions that no human has ever experienced before. We're becoming explorers of our own planet, pioneers in landscapes that are both familiar and completely alien. And this is just what we've discovered in the first few months. The former ocean floors cover more area than all the continents combined. Most of it is still unexplored, still hiding secrets that could change everything we thought we knew about Earth, about life, about our own history and future. The blue planet is gone, but what it's left behind is a treasure trove that will take centuries to fully explore and understand. But now we need to talk about something that's going to hit much closer to home. Because all of these amazing discoveries and geological wonders don't mean much if human civilization collapses in the process. And I have to tell you, for a while there, it really looked like that's exactly what was going to happen. Within 24 hours of the oceans disappearing, 2 billion people lose their primary food source. 2 billion. That's more than a quarter of everyone on Earth suddenly facing starvation, not because of war or natural disaster, but because the fundamental source of protein that their societies depend on simply doesn't exist anymore. Think about Japan for a moment. This island nation has built its entire culture around the sea. Fish and seafood make up 60% of the protein in the average Japanese diet. Fishing has been central to Japanese identity for thousands of years. The techniques, the traditions, the entire economic structure of coastal communities, all of it based on harvesting food from the ocean. Overnight, none of that exists anymore. 60 million Japanese people wake up in a country where the primary food source has vanished. The social and economic disruption is immediate and catastrophic. Fishing fleets that employed hundreds of thousands of people suddenly have no purpose. Coastal towns that have existed for centuries face complete economic collapse. But Japan isn't alone. Norway, Iceland, the Philippines, much of coastal Africa, island nations throughout the Pacific and Atlantic, anywhere that depends heavily on marine protein, faces the same crisis. It's not just about individual people going hungry. It's about entire economies, entire ways of life disappearing overnight. Singapore is probably the most dramatic example of how quickly modern civilization can unravel when its foundations disappear. This city-state built its entire existence on being a shipping hub, a port that connects the trade routes between Asia, Europe, and the Americas. 80% of Singapore's economy is directly tied to maritime trade and shipping. When the oceans disappear, Singapore doesn't just lose its economic base, it loses its reason for existing. Within 12 hours, the government declares martial law as the population realizes that their highly developed, technologically advanced city has suddenly become completely unsustainable. There's no food production, limited fresh water, and no way to import the resources that 6 million people need to survive. The social order breaks down with shocking speed. This isn't a gradual economic recession or a natural disaster that communities can adapt to over time. This is the complete elimination of the foundation that modern civilization is built on, global trade carried by ocean shipping. 90% of global trade moves by ship. 90%. All those container ships carrying everything from food to electronics, to raw materials between continents, none of that works anymore when the ships are sitting on dry sea floor and there's no water to carry them. Global supply chains don't just get disrupted, they cease to exist. Miami, once a vibrant coastal city and major port, now sits 20 miles from the nearest water. The Great Lakes are the closest significant bodies of water, and they're not connected to the sea anymore. The port of Miami, which handled millions of tons of cargo annually, is now a collection of empty warehouses and abandoned shipping equipment, sitting next to a dry crater where Biscayne Bay used to be. But here's where human ingenuity starts to shine through the crisis. Because while some places collapse, others adapt with a speed and creativity that's genuinely inspiring. The Netherlands provides one of the most remarkable examples of adaptation under pressure. Historically, the Dutch have been fighting the sea for centuries, building dikes and polders to reclaim land from the ocean. Half of the Netherlands is below former sea level. which made it vulnerable to flooding, but also gave the Dutch unparalleled expertise in water management and engineering. When the oceans disappear, the Netherlands suddenly finds itself sitting on valuable high ground. What used to be below sea level is now elevated terrain, in a world where the former ocean basins are the new low points. Dutch water management expertise, previously used to keep the sea out, becomes incredibly valuable for managing the limited fresh water resources that remain. Within weeks, the Netherlands becomes the new center of European civilization. The country's experience with large-scale engineering projects allows them to quickly adapt their infrastructure to the new reality. The old polder systems are converted into advanced agricultural areas. The extensive canal networks are modified to distribute fresh water from the remaining rivers and lakes. Most importantly, the Dutch approach to this crisis with the same methodical, engineering-focused mindset that has characterized their relationship with water for centuries. They don't panic, they problem-solve. They start developing technologies and techniques that other countries desperately need to learn. Israel provides another inspiring example of adaptation. This country has been dealing with water scarcity for its entire existence as a modern nation. Israeli desalination technology is the most advanced in the world, capable of turning seawater into fresh water more efficiently than anyone else. But with the oceans gone, desalination doesn't help. Instead, Israeli engineers pivot to atmospheric water harvesting, pulling water directly out of the air. The technology existed before the oceans disappeared, but it was expensive and energy-intensive compared to just pumping water from rivers or desalinating seawater. Suddenly, with most traditional water sources unavailable, atmospheric water harvesting becomes not just viable but essential. Israeli companies develop machines that can extract 100,000 gallons of water per day from air, even in relatively dry climates. These machines use solar power and advanced filtration systems to condense water vapor from the atmosphere, providing a reliable source of fresh water that doesn't depend on rainfall or existing water bodies. The technology spreads rapidly to other water-scarce regions. Within 3 months, atmospheric water harvesting installations are being built in Australia, the southwestern United States, and parts of Africa that are now completely cut off from traditional water sources. Japan, facing the collapse of its fish-based diet, develops what they call sky farms, massive agricultural installations built in the former submarine canyons off their coast. These canyons, now dry valleys that extend down thousands of feet below the former sea level, provide natural protection from the extreme weather conditions and temperature fluctuations that affect the surface. The deep canyons maintain more stable temperatures than the surface, making them ideal for controlled environment agriculture. Japanese engineers build terraced farming systems that use advanced hydroponics and artificial lighting to grow vegetables and grains in conditions that would be impossible on the surface. These sky farms aren't small operations. The Monterey Canyon installation, built in partnership with California, covers 50 square miles of terraced growing areas and produces enough food to feed 2 million people. It's like someone carved a massive greenhouse complex into the side of an underwater mountain. Except the mountain is now exposed to air, and the greenhouses are producing food instead of fish. Russia, with its vast landmass and numerous inland water sources, finds itself in a surprisingly advantageous position. Lake Baikal, the world's largest freshwater lake by volume, suddenly becomes one of the most valuable resources on the planet. Russia starts ice mining, harvesting ice from polar regions and glaciers and transporting it to areas that need fresh water. The scale of these ice mining operations is staggering. Massive icebreakers, previously used for Arctic shipping, are converted into ice harvesters. They carve up icebergs and glacier edges, loading enormous blocks of ice onto transport vehicles that carry them thousands of miles to areas experiencing water shortages. It sounds primitive compared to high-tech solutions like atmospheric water harvesting, but it works. A single large iceberg contains enough fresh water to supply a major city for months. And unlike technology-dependent solutions, ice mining can be scaled up quickly using equipment and expertise that already exists. But not all the responses to the crisis are inspiring. Some are absolutely horrifying and show the worst of human nature under extreme stress. North Korea, facing complete isolation now that sea-based trade is impossible, launches missile attacks on China's lake regions, demanding tribute payments of fresh water in exchange for not targeting population centers. It's the first time in history that fresh water becomes the explicit target of international warfare. The water wars that follow claim 10 million lives in the first year. Countries with significant freshwater resources find themselves under attack from neighbors who have none. The Congo River Basin becomes a battleground as multiple African nations fight for control of one of the few remaining major river systems. The Great Lakes region of North America sees armed conflicts between the United States and Canada over water allocation rights. Lake Victoria, shared between Uganda, Kenya, and Tanzania, becomes the center of a three-way war that displaces millions of people. The scale of suffering is enormous, but it's also tragically predictable. When people face the choice between fighting for water and dying of thirst, most choose to fight. Some of the conflicts get resolved through diplomacy and cooperation, but others escalate into full-scale wars. The Middle East, already a region of water scarcity, erupts into conflicts that make previous regional wars look minor by comparison. Israel's atmospheric water harvesting technology becomes a military target. Countries that had never been enemies find themselves fighting over river rights and lake access. But remarkable cooperation emerges too, often in the most unexpected places. The Indo-European water pipeline becomes the fastest mega-project in human history. This massive engineering undertaking connects the remaining Himalayan glaciers and alpine lakes to population centers throughout India and Europe. Through a pipeline system that spans 3,000 miles, the project is completed in 11 months, a timeline that would have been impossible under normal circumstances but becomes achievable when the alternative is the collapse of civilization. Multiple countries contribute resources, expertise, and labor. Traditional enemies work side by side because everyone recognizes that survival depends on cooperation. The pipeline uses a combination of traditional pumping technology and innovative atmospheric pressure systems that take advantage of the altered air pressure conditions in the former ocean basins. Water flows from high-altitude sources down through the former Mediterranean basin and up to population centers, using the extreme elevation changes to assist in moving massive volumes of water. It's an engineering marvel that rivals the construction of the pyramids or the Panama Canal. But it's built in less than a year because the entire future of human civilization depends on it working. Iceland opens its borders and declares itself humanity's lifeboat. This small island nation, with its geothermal power plants and glacier-fed rivers, suddenly finds itself with some of the most valuable resources on Earth. Instead of hoarding these resources or using them as leverage in international negotiations, Iceland makes the remarkable decision to welcome climate refugees from around the world. The population of Iceland grows from 300,000 to over 2 million in 6 months as people flee water-scarce regions. The integration challenges are enormous, but the Icelanders approach it with the same practical mindset that has allowed them to thrive in one of the world's most challenging environments. Geothermal power plants are expanded rapidly to provide energy for the growing population. Glacier melt is carefully managed to provide fresh water. Most remarkably, Iceland starts sharing its geothermal expertise with other countries, helping them develop alternative energy sources that don't depend on ocean-based systems. The Icelandic model becomes a template for how small nations with limited but valuable resources can play outsized roles in global survival efforts. It demonstrates that cooperation and resource sharing, rather than competition and hoarding, might be the key to humanity's survival in the post-ocean world. But perhaps the most important lesson from this period of crisis and adaptation is that human civilization is far more resilient than anyone imagined, but also far more fragile. The systems that seemed permanent and unshakable, global trade, food distribution, communication networks, proved to be surprisingly vulnerable to disruption. But human creativity and adaptability proved to be stronger than the systems themselves. Within a year of the oceans disappearing, new networks of cooperation emerge. New technologies develop at unprecedented speed. New economic systems evolve to handle resources and trade in ways that don't depend on ocean shipping. Humanity doesn't just survive the immediate crisis, it starts building something new. But the planet that's emerging from this transformation is barely recognizable as the Earth that humanity grew up on. And the most dramatic changes are still to come. 5 years later, if you could somehow visit this transformed Earth, you would barely recognize it as the same planet. The changes go so far beyond just missing oceans, that it's like visiting an alien world that happens to have familiar-looking humans living on it. Let me paint you a picture of what Mariana City looks like, because it represents everything remarkable and terrifying about how humanity has adapted to this new reality. Built in what used to be the Mariana Trench, this city extends 7 miles down into the earth, using the natural insulation of the deep trench to protect its inhabitants from surface temperature swings that now range from -100 degrees Fahrenheit to +150 degrees. 7 miles down. To put that in perspective, that's deeper underground than most mines have ever gone, deeper than any permanent human settlement in history. But it's not underground in the traditional sense. It's built into the walls and floor of what used to be the deepest part of the ocean, a natural canyon system that's now exposed to air for the first time in hundreds of millions of years. The architecture is unlike anything that's ever been built before. Multi-level structures are carved directly into the rock walls of the trench, connected by massive elevator systems and networks of tunnels. The deepest levels of the city maintain a stable temperature year-round, while the upper levels can be sealed off when surface conditions become extreme. Transportation between cities happens along the former shipping routes. But instead of ships, maglev trains run across the exposed ocean floor at speeds that would have been impossible when the routes were underwater. The train from Mariana City to New Pacific City, built where Los Angeles used to meet the sea, covers the distance in 4 hours. Traveling across terrain that no human had ever seen before, the oceans disappeared. Picture looking out the window of one of these trains as it races across the former Pacific floor. You're traveling through landscapes that are simultaneously alien and familiar, past underwater mountain ranges that are taller than anything on the original continents, through valleys that were carved by deep ocean currents over millions of years. The whale graveyards are particularly haunting. Massive skeletons of blue whales, sperm whales, and other giant marine mammals lie scattered across the seafloor like monuments to a lost world. Some have been preserved as memorials, others have become the foundations for new ecosystems as plant and animal life adapts to the changed world. Weather in this new Earth follows patterns that meteorologists are still trying to understand. Without oceans to moderate temperature, continental climates dominate everywhere. Siberia, which used to be one of the coldest places on Earth, now experiences temperature swings that go from 120 degrees Fahrenheit in summer to -100 degrees in winter. The Amazon rainforest, deprived of the moisture that used to evaporate from the Atlantic and get carried inland by trade winds, has become a desert. Not a gradual transition over decades, but a rapid die-off of the forest ecosystem within 2 years of the oceans disappearing. Where there used to be the world's most biodiverse forest, there's now a landscape that looks more like the Sahara, but the most productive farmland on Earth is now in the Pacific Northwest seafloor. The volcanic soil, enriched by eons of ocean sediment and volcanic activity from underwater vents, supports plant growth that's almost magical in its abundance. Wheat grows 20 feet tall. Vegetables reach sizes that would have been considered impossible under normal conditions. The soil chemistry is so rich that normal fertilizers aren't just unnecessary, they're actually harmful. The natural nutrients in the former seafloor are so concentrated that farmers have to learn entirely new approaches to agriculture. Traditional farming knowledge becomes useless when the soil contains mineral concentrations that no land-based farmer has ever encountered. New life forms continue to emerge at a rate that biologists can't keep up with. The cliff runners are descendants of mountain goats that have adapted to navigate the exposed continental shelves. Their hooves have evolved to grip rock surfaces better, and they've developed an almost supernatural ability to find stable footing on the unstable geology of the rebounding seafloor. Sand dolphins represent one of the most remarkable evolutionary developments. These creatures evolved from mudskippers that were stranded in the former ocean basins. In 5 years, they've developed pack-hunting behaviors and echolocation abilities that allow them to navigate the complex terrain of the exposed ocean floor. They're not fish anymore, but they're not quite land mammals either. They're something entirely new. The crystal gardens are perhaps the most alien-looking new ecosystems. In areas where salt water evaporated and left behind concentrated mineral deposits, specialized plants have evolved that can tolerate extremely high salt concentrations. These plants incorporate the minerals into their structures, creating forests that literally sparkle in the sunlight. Walking through a crystal garden is like walking through a fantasy landscape. Trees with silver bark that contains actual silver deposits. Shrubs with leaves that glitter with crystalline formations. Flowers that chime in the wind because their petals contain mineral formations that resonate at specific frequencies. But the most profound change might be in humanity itself. Children born after the oceans disappeared show physical adaptations that suggest human evolution is happening at an accelerated pace. Lung capacity has increased by 30% in just 2 generations. The cardiovascular systems of post-ocean children are more efficient at extracting oxygen from the thinner air. Most remarkably, children born after the draining demonstrate an ability to navigate by magnetic fields. The Earth's magnetic field, no longer moderated by the conductive salt water of the oceans, is stronger and more variable than it used to be. These children can sense magnetic north with an accuracy that rivals a compass, and some can detect magnetic anomalies that indicate underground metal deposits or geological instabilities. Scientists think this magnetic sensitivity developed because surface navigation became so important in a world where traditional landmarks disappeared and GPS systems remained unreliable. Children who could sense direction magnetically had survival advantages, and this trait spread rapidly through populations that were struggling to adapt to the new environment. The psychological changes in humanity might be even more significant than the physical ones. Growing up in a world without oceans creates a fundamentally different relationship with nature and the planet. These children have never seen a naturally occurring body of water larger than a lake. They've never heard the sound of waves or experienced the rhythmic motion of tides, but they've also grown up with access to wonders that previous generations could never imagine. They can walk across the former Atlantic Ocean. They can explore underwater mountain ranges and deep-sea canyons. They can see geological formations and historical artifacts that were hidden for millions of years. Museums develop memory programs where the last generation to see oceans shares their experiences with children who will never see them. Virtual reality installations try to recreate the experience of swimming in the ocean or walking on a beach. But the children who use them often say that the simulations feel fake and alien. It's like there are now 2 different species of human, those who remember the blue planet and those who only know the transformed world. The generational divide isn't just about different experiences. It's about fundamentally different ways of understanding what Earth is and what it means to be human on this planet. Cities develop around the remaining freshwater sources with architectural styles that reflect the new reality. Buildings are designed to capture and store atmospheric moisture. Underground facilities protect against the extreme temperature swings. Transportation systems are built to handle the ongoing geological instability. As the seafloor continues to rebound and settle, the economic systems that emerge bear little resemblance to the pre-ocean loss global economy. Trade happens along the former shipping routes, but it's carried by land-based vehicles and aircraft. Resource extraction focuses on the former ocean floors, where millions of years of accumulated minerals and rare earth elements are now accessible. Energy production shifts toward geothermal and solar systems that can handle the extreme weather conditions. The former ocean basins, with their temperature stability at depth and their exposure to intense surface sunlight, become ideal locations for energy generation facilities that would have been impossible to build in the old world. But perhaps most importantly, human society becomes fundamentally more cooperative out of necessity. The challenges of surviving in the transformed world are so enormous that competition between nations becomes a luxury that no one can afford. International boundaries become less important than resource-sharing agreements and technological cooperation. The United Nations evolves into something more like a global survival coordination organization. Instead of mediating disputes between sovereign nations, it coordinates massive engineering projects, resource distribution, and population movements that are necessary for human survival on the transformed planet. It's not a utopia. There are still conflicts, inequalities, and suffering. But the scale of the challenges forces humanity to think and act as a species rather than as competing nations or cultures. The transformed Earth doesn't care about human politics or historical grievances. It demands cooperation or extinction, and somehow, remarkably, most of humanity chooses cooperation. But now I want to take you deeper into what this transformation really means, beyond the practical adaptations and new technologies. Because what we're really talking about is the death of one planet and the birth of another. And that change goes all the way down to the fundamental physics and chemistry that make Earth work. The oceans weren't just Earth's most prominent feature, they were Earth's identity. For 4 billion years, ever since the first water vapor condensed from the early atmosphere and began forming the first seas, this planet has been defined by its water. The very chemistry of life, the way energy flows through ecosystems, the way heat moves around the planet, the way the atmosphere behaves, all of it based on the presence of vast bodies of liquid water. Without the oceans, Earth operates on fundamentally different principles. It's not just that we have a planet without water. We have a planet where the basic systems that regulate temperature, weather, and atmospheric chemistry work in ways that have never existed before in the 4 billion-year history of our world. The carbon cycle, which has regulated Earth's climate for hundreds of millions of years, is broken beyond repair. Normally, carbon dioxide dissolves in ocean water, where it's absorbed by marine organisms and eventually deposited on the seafloor as limestone and other carbon-containing rocks. This process removes excess carbon dioxide from the atmosphere over geological timescales, preventing runaway greenhouse effects. With the oceans gone, that regulatory system simply doesn't exist anymore. Carbon dioxide from volcanic activity, decomposition, and human industrial processes accumulates in the atmosphere with nothing to remove it. Earth locks itself into perpetual greenhouse conditions that get more extreme every year. The water cycle becomes a closed loop around the scattered remaining lakes and rivers. Instead of the massive evaporation from ocean surfaces that used to drive weather patterns around the world, water now only evaporates from much smaller sources. This means that areas that used to receive regular rainfall from moisture that evaporated thousands of miles away become permanently arid. But the most fundamental change is happening deep within the Earth itself. Plate tectonics, the slow movement of Earth's crustal plates that has shaped continents and ocean basins for billions of years, begins to slow down and eventually stops altogether. Here's why. The movement of tectonic plates depends on the subduction of oceanic crust, the process where the seafloor gets pushed under continental plates at the edges of oceans. This subduction is lubricated by water that penetrates into the rock and reduces friction between the moving plates. Without oceans, without the constant cycling of water into subduction zones, the plates lose their lubrication and begin to lock up. Within a decade of the oceans disappearing, the tectonic plates stop moving. This might sound like a good thing. No more earthquakes from plate movement, no more volcanic activity from plate boundaries, but it's actually catastrophic for the long-term stability of the planet. Plate tectonics isn't just about earthquakes and volcanoes. It's about recycling the planet's crust, bringing fresh minerals to the surface, regulating the heat flow from Earth's interior, and maintaining the magnetic field that protects us from cosmic radiation. Without active plate tectonics, Earth begins to cool from the inside out, and the magnetic field starts to weaken. But life, as always, endures through sheer tenacity and adaptability. In the most unlikely places, new forms of life continue to emerge and thrive. The extremophile bacteria that used to live around deep-sea volcanic vents adapt to the new surface conditions and become the foundation for entirely new ecosystems. These bacteria can tolerate temperature extremes, high radiation levels, and chemical conditions that would kill most other life forms. As Earth's protective magnetic field weakens and more cosmic radiation reaches the surface, these radiation-resistant bacteria become increasingly important as the base of food webs in the harshest environments. Some of the most remarkable new life forms develop in the former deep ocean trenches, where pockets of water remain trapped and isolated from the surface. These isolated water bodies become evolutionary laboratories, where life develops along completely different paths than anything that existed in the original oceans. In the Japan Trench, now a dry canyon system, small pools of hypersaline water support ecosystems that look more like something from Mars than Earth. The organisms that live in these pools have adapted to salt concentrations that are 5 times higher than the original ocean. They've developed biochemistry based on different elements and energy sources than conventional Earth life. Most remarkably, some of these organisms appear to be developing silicon-based rather than carbon-based biochemistry. Silicon can form complex molecules similar to carbon under certain conditions, and the extreme chemical environment of the hypersaline pools seems to favor silicon-based chemistry over carbon-based. If this is really happening, and the research is still preliminary, it represents the emergence of an entirely new form of life on Earth, not just new species or new adaptations, but life based on fundamentally different chemistry than anything that has existed on our planet before. Humans create memory museums throughout the new cities, preserving not just artifacts from the ocean world, but the actual sounds of what's been lost. Whale songs, recorded in the years before the oceans disappeared, play in vast chambers that try to recreate the acoustic environment of the deep sea. The sound of waves crashing on beaches, the calls of seabirds, the creaking of ships, all preserved as audio, artifacts from a lost world. Children born after the draining listen to these recordings with the same sense of wonder and disbelief that we might feel listening to recordings of dinosaurs, if such things existed. Rain, which once fell everywhere, becomes something that children learn about from historical recordings. The concept of precipitation over land areas seems as alien to them as the idea of water falling from the sky might seem to inhabitants of Mars. The last generation to see oceans becomes living libraries, their memories more precious than any written record. These people carry in their minds the knowledge of what it felt like to swim in the ocean, to feel the pull of tides, to watch the sun set over an endless expanse of water. As they age and pass away, they take with them sensory experiences that no human will ever have again. But perhaps the most profound discovery comes from studying the exposed ocean floor itself. Layer by layer, scientists read 4 billion years of Earth's history in sediments that would have taken centuries to drill through when they were underwater. They find evidence of previous mass extinctions, climate changes, and evolutionary events that were completely unknown before the oceans disappeared. Most startling is the discovery that Earth's oceans have disappeared before. Not completely and not permanently, but the geological record shows several events where ocean levels dropped dramatically over short time periods. The most significant of these events occurred 65 million years ago, coinciding with the asteroid impact that killed the dinosaurs. The evidence suggests that the asteroid impact temporarily vaporized a large portion of the world's oceans. For approximately 3 days, Earth had dramatically reduced ocean levels before the vaporized water condensed and returned as the most intense rainfall in planetary history. Life barely survived that event, and the fossil record shows that it took millions of years for marine ecosystems to fully recover. But this time is different. This time, there's no asteroid impact that will reverse itself. This time, there's no mechanism for the water to return. Earth is writing an entirely new chapter in its biography, and there's no previous example to suggest how this story ends. The most humbling discovery comes from the deepest ocean trenches, where scientists find evidence of life forms that predate DNA itself. These ancient biochemical systems suggest that life on Earth began in ways that differ from every current theory about the origin of life. They hint at forms of biochemistry that existed before the genetic systems that all current life is based on. In the Puerto Rico Trench, researchers discover what appear to be fossilized structures that show organization and complexity, but don't match any known biological or geological processes. Some scientists speculate that these structures represent a form of life so ancient and so different from modern life that we don't have adequate concepts to understand what they were. These discoveries fundamentally change our understanding of what life is and what it can become. They suggest that the transformation Earth is undergoing might not be unique in planetary history, that the cycles of creation and destruction that shape worlds might operate on timescales and through processes that dwarf human comprehension. As the years pass and Earth continues to evolve into something unprecedented, humanity faces a choice that goes beyond mere survival. We can try to recreate the old world using technology and engineering, building artificial oceans and enclosed ecosystems that approximate what was lost. Or we can embrace the transformation and learn to thrive in the alien world that Earth has become. The children who never knew oceans seem to intuitively understand something that the older generations struggle with. This new Earth isn't a damaged version of the old one. It's a completely different planet with its own beauty, its own possibilities, and its own forms of life. Learning to love this transformed world might be the key to humanity's long-term survival on it. The blue planet is dead, and there's no bringing it back. But what's being born in its place might be stranger and more wonderful than anything we lost. The question isn't whether humanity can survive the transformation. We already have. The question is whether we can learn to call this alien Earth home, and that story is still being written. One day at a time, under skies that have never been seen before, over landscapes that have never existed, by people who are becoming something that humanity has never been. The greatest adventure in human history isn't behind us in our exploration of the oceans. It's ahead of us, as we learn to live on a world that we're still discovering, that we're still helping to create, that we're still learning to love.